Hey, what's up, you guys? Welcome back to another episode of Physics. And in today's episode, we're gonna do the multi-particle system. Sounds fun. And in today's chapter, they teach you two main things, and those two things are the real systems and the point particle system. And as you can see from those two words, and the little phrase that says system, that means that you need to draw systems. You need to draw lots of systems out. But it's a very easy chapter. You will get it in one go. I know it because it's very simple. So into this problem, it's a very simple problem. It's just a yo-yo problem. And as you see right here, this line, that line's your hand. It's just I don't have any artistic level to draw a hand here, so I just drew a line. So let's imagine that line is my hand, like right now, my hand. And this hand exerts a force, up and down to play with the yo-yo, and this yo-yo goes down and it changes a certain height. And the question is asking two things: why is the change in translational energy, and B is why is the change in rotational energy. Now, to do part A, what would be better to use, the point particle system or the real system? Well, if you use the real system, you know what other factors are here in this system. So for the translational energy, it's just very simple to use the point particle system, where work equals the translational energy. So in part A, we're going to use the point particle system. And what is my system? Well, my system is the center mass of my yo-yo. So I know that work equals the change in energy, and I can define work as the force net times distance. So I know that the force is the two forces that are acting in my drawing. They're just two forces. One is the force upwards that my hand is acting on the yo-yo, and the force downwards because of the mass and the gravity pulling it downwards, gravity of Earth. So I know that this will be just F minus mg, minus because it's downwards. This is going down. And what is d? Well, d is just the distance from here to here that your is going, so it will be h. So I know that mg minus fh will be my k trans. Now let's go to part B, changing rotational energy. Now, to find rotational energy or any other type of energy that is not just transitional energy, you're gonna use the real system. But to use the real system, you need translational energy, so you need to do part A before you do part B. So yeah. So first we need to know what our system is. So I know that my system is the yo-yo plus the string. And I know that work equals the change in energy. And I know that change in energy is K trans plus K rotational. And this needs to be equals work. And I need to find out work. What is work? So here is where you need to see what's going on. So if my hand is applying, every time it moves up and down, it's applying a force to the yo-yo, I'm calling that S. Because S is the point of application of the force I'm doing with my hand, like up and down. And so Fs, the force that I'm applying with my hand, plus the force that I'm applying downwards, that will be mg, g for Earth, minus h, the h of the yo-yo, how much is traveling. So I know my K trans from part A, so I know that K trans is mg minus f times h, plus the K rod equals fs plus a negative mg minus h. And I'm trying to find this, so I'm moving I'm moving this to this side, so I have this K rod fs plus mgh minus mg minus f times h. And if I distribute the h out, and if I distribute the h out, this is equal to this, so this will cancel. So fs plus fh, if I pull the f out, I will have f times S plus H, and this will be the change of rotational energy of the yo-yo. So thank you very much for listening to me out. If you need any other help in other physics problems, please let me know and I will do it for you. Thank you.